you see the board and hear me okay? Sorry for all my complaining. It's been a rough morning. All right, we're gonna we're working in section 4.4 and 4.7 right now. There's like multiple parts that kind of go with each section. All right, so I have been telling you guys that when you solve a quadratic equation, the answers you get to that equation are the x-intercepts of its graph, right? So you either get two different answers, and that means the parabola crosses the x-axis at two different x values, two different numbers. You either get the same answer twice, so then you find out that it's the vertex that actually touches the x-axis. And then I said to you guys, hey, good morning.
Morning.
What's going on? Me?
Well.
Allie, did you Not yet. I haven't heard of it. Yeah, I'm going tomorrow.
Oh, okay.
Okay. Sorry, guys. All right. And then there was a third scenario. What happens with those parabolas that don't cross over the x-axis? What do you get when you solve an equation that it doesn't have any x-intercepts? And I've kind of been hinting towards you guys that you don't get a real number when you solve these quadratic equations. You get an imaginary number, which I know sounds like, wait a minute, what are you talking about? You are now going to live in a world of math where you get real number answers and then you get imaginary number answers. So guys, these are numbers that we can physically use in a math problem, but they don't exist on a real number line. It's not a real number. It's literally an imaginary number that we can use in a math problem because there is a use for them in higher level math. However, it's not something that you would ever find on a real number line or a real coordinate plane. That's why you don't cross over the x-axis, because his x-intercepts are imaginary numbers. They're not real on this real x-axis, okay? So I have to kind of explain to you what an imaginary number is so we can start getting these imaginary answers, all right? So let me move mine up. All right, so here we go. Imaginary numbers. When you take the square root of a negative number, the answer is an imaginary number. So guys, if I asked you, what's the square root of negative 25? If you tried to take the square root of a negative number, well, just think about what that's asking you. If you take the square root of a negative number, it's asking you, what did you square, or what did you times by itself 2 times to equal negative 25? It's literally asking you, what times what equaled negative 25? What did you square to equal negative 25? And guys, the problem is, there's no number, there's no real number that you could times by itself twice that would end up equaling a negative. Think about it. If this was 5, well, 5 times 5 won't equal negative 25. And you say, oh, it must have been negative 5. Well, negative 5 times negative 5 wouldn't multiply to negative 25. There's no real number to this problem. You cannot square a real number and the answer to that end up being negative. So that means if you try to take the square root of a negative number, you don't get a real number. You get an imaginary number because there is a need in upper level math to take the square root of a negative number. We're going to need to do that. But we have to remind ourselves that it's not a real number that we get, it's an imaginary number that you get. All right, so since no real number squared can equal a negative number, the imaginary number I, they call it I, the imaginary number, was created as a way to deal with the square root of a negative number in higher level mathematics, okay? So here we go. The imaginary number I, we use I to represent this imaginary unit. So they said, let I be the number whose square is negative 1. They're like, let there be a number out there that when you square it, it ends up being negative because there's no such real number. There is no real number that when we square it, we get a negative answer. All right, and again, mathematicians way back in the day, they created this number. Why did they let it be negative 1? Guys, they had all the control. They created this number. Why let it be negative 1? Why not let I be the number whose square is -2? Or 8's my favorite number. Why not let I be the number that when you square it, it equals -8? The reason they chose -1 over all other possible numbers is because -1 divides evenly into every single number that exists in this world. So it's very compatible with other numbers by letting this imaginary number be -1, okay? All right, so here we go. So that means if they're gonna let I be the number whose square is -1, that means I squared is -1. He's the number that when you square him, you get -1. And guys, if that's true, if I squared equals -1, then when I square root it, I is gonna be equal to the square root of -1. So that's it. So I've put boxes around it. When it comes to the imaginary number I, these are the two things you need to know. You need to know that I squared is -1, and you need to know that I himself is the square root of -1. And that's how we're gonna use them. All right, so all I wanna do today is basically show you how you can take the square root of a negative number now and get an imaginary answer to it. So guys, if you take the square root of a negative number, your answer is going to be imaginary. There's going to be some imaginary unit in your answer, okay? All right, let's do it. So I said simplify the following square roots. So guys, let's say you were asked to take the square root of -16. Notice you are taking the square root of a negative number. The answer has to be imaginary. There's no real number answer to this. They are literally asking you, what number could you times by itself 2 times to equal -16? There is no real number that will do this. So to simplify a negative square root, this is what you do. First, you factor out the square root of -1. You factor out the I, the imaginary part. So we're gonna break this up into the square root of -1 and then the square root of +16, right? Because -1 times +16 is -16. Now, you're gonna replace the square root of -1 with I. So now he becomes the imaginary part of your answer. And now you deal with this square root accordingly. It's a positive square root now, so now you deal with it just like you normally would. Guys, who's the square root of 16? It's 4. So you are left with, what is I times 4? 4I. Then you kind of treat I like a variable, like x. X times 4 would be 4x, I times 4 is 4I. So guys, the square root of -16, it's not 4, it's not a real number, it's an imaginary number. It's 4I. So if you take the square root of a negative number, you should get an imaginary answer. And that I is saying that your answer is imaginary. So guys, now watch this. So this is the number they're saying that if you times it by itself 2 times, you get -16. So watch. 4I times 4I should equal this negative number. What's 4 times 4? 16. What's I times I? I squared, right? I times I is I squared. Who's I squared? I squared is -1. So 16 times -1, it's -16. 4I is the number that when you times it by itself twice, you get -16. Everybody okay? I know this is wild, you know, this is literally mind-bending. You're like, wait a minute, we got imaginary numbers now? Yes, we do. And you will get an imaginary number every time you take the square root of a negative number. All right, let's practice this. Let's do it again. Tomas, you okay?
Yeah.
Crazy. All right, so guys, let's say you had to take the square root of -81. Right away, we know there's no real number answer to this. So the first thing we're gonna do is break it up into the square root of -1 times the square root of 81. Take out the square root of -1. Now, replace the square root of -1 with I. That's how we're gonna get an imaginary answer. Now, deal with the square root of 81 accordingly. Guys, who's the square root of 81? It's 9. So you have I times 9. The answer is 9I. So basically, if I took the square root of 81, the answer is 9. If I take the square root of -81, the answer is 9I. It's an imaginary number, not a real number. look at the next one. What if I had to take the square root of negative 49? That's not okay, guys. You can't take the square root of a negative number and get a real answer to that. So we're going to break it up into the square root of negative 1 times the square root of positive 49. Well, the square root of negative 1, guy, that's I. That's the imaginary unit. And then the square root of 49 is 7. So I times 7 is 7i. So the square root of negative 49 is not 7, it's 7i. Does that make sense, Tomas? Okay. So again, this is not a number that you could physically see on a real number line or a real graph coordinate plane, but it is an answer that satisfies that question, okay? All right, look here. What if you had to take the square root of negative 24? First things first is get that negative 1 out. Get that imaginary unit out of there. So break it up into the square root of negative 1 and the square root of 24. All right, the square root of negative 1, that's our I. That's our imaginary unit. Now the square root of 24. Guys, we can't take the square root of 24. 24 is not a perfect square, but I can simplify it like I normally would have. What's the biggest perfect square that goes into 24? It's 4. So now I can break it up into the square root of 4 times the square root of 6. So you're still going to simplify that second number accordingly. All right, now let's go through. I times the square root of 4, guys, that's 2. And then the square root of 6 is the square root of 6. I can't simplify that, so that radical has to stay. And then the way you write your answer, I and 2 are no longer under square roots. So we can multiply them together. I times 2 is 2i, and then it's multiplied with the square root of 6. So you write it as 2 times I times the square root of 6. The important part is every single time you take the square root of a negative number, I is somewhere in your answer. You have to have I somewhere in your answer. All right, what about this one? The square root of negative 125. Well, first I'm going to take out the negative 1, and then that leaves me with 125. The square root of negative 1, that's I. That's the imaginary part of our answer. Now I can deal with the square root of 125. He's not a perfect square, but what's the biggest perfect square that divides evenly into him? 25. So I can break that up into the square root of 25 times the square root of 5, because 25 times 5 is 125. All right, let's go through and clean it up. That's going to be I times, who is the square root of 25? 5, and then you times it with the square root of 5 that we can't simplify and we can't get rid of. So now on the outside, no longer under a square root, is I times 5, which is 5i, and then you times it with the square root of 5. So my answer is imaginary. It has an I in it. You guys okay? Everybody at home, thumbs up? Excellent. And again, for those of you with your camera on, I cannot thank you enough. That they should be on. All right, now look here. The square root of negative 10. First, we break it up into the square root of negative 1 times the square root of positive 10. The square root of negative 1, guys, that's I. That's our imaginary unit. But then you go to the square root of 10, and let's say you can't take the square root of him. Does he simplify? Do any perfect squares divide evenly into 10? No. So he's already a simplified square root, so he literally just becomes I times the square root of 10. It's an imaginary number. It is not on the real number line or the real coordinate plane, which is why his x-intercepts are not real. This would be a parabola that does not cross over the x-axis. All right, last one. The square root of negative 58. I know the answer has to be imaginary. I can't take the square root of a negative number and get a real answer to that. So I'm going to break it up into the square root of negative 1 times the square root of positive 58. The square root of negative 1 is I. Now we go to the square root of 58. I can't take the square root of 58 because he's not a perfect square. But do any perfect squares divide evenly into him? Let's see. What's the closest one? 49, 36, 25, 16, 9, 4. No. So he is a simplified square root as well, and he would just stay the square root of 58. So your answer is I times the square root of 58. All right, can I get a thumbs up? Everybody okay? So again, it's just like what we were doing last week when you were simplifying square roots, except now every single answer has to have an I in it because every single square root is a negative number. So now it's the same process, it's just your answer has to have an I in it. It has to be an imaginary number to make that statement true. All right, I threw this one in here because I wanted you guys to be careful. Every now and again, they'll give you like some operations to do, like, oh, take the square root of -4 and times it with the square root of -9. Now, when you are taking the square root of a negative number and they're both negative, it's kind of like all bets are off. I don't want you guys to do this. I don't want you guys to be like, oh, look, the square root of -4 times the square root of -9 is the square root of -4 times -9 is positive 36, and now the answer is 6. I don't want you guys to do that because that's wrong. Because we know that there are definitely some i's, some imaginary numbers involved with the square roots of these numbers. So now watch what happens. So technically the square root of -4, guys, that's the square root of -1 times the square root of 4. Times, this is the square root of -1 times the square root of 9. So really I get I times 2, because 2 is the square root of 4, times I times 3. So I get 2I times 3I, which is going to be 2 times 3 is 6. I times I is I squared. Who did we say I squared was? Guys, look on the front of your notes. Who's I squared? I squared is -1. So this ends up being 6 times -1. So the answer to this is -6. It's not positive 6, it's -6. You lose a factor of I squared when you try to multiply them together first. So the moral of the story is, if you're going to multiply negative square roots together, you have to simplify them first. You have to take out their i's, and that sounds terrible. You have to take out their i's, and then you can simplify your radicals accordingly. But you can't multiply right away because you don't get the correct answer. Okay, I just wanted to show you that just in case it pops up in the future, that we always have to simplify our radicals first when it comes to working with negative ones, okay? All right, now let me show you how this will apply. So go down to the bottom of your notes.
I'm sorry. No, I'm sorry.
Okay, so guys, let's pretend you were asked to solve the following quadratic equations, right? Well, you know how to solve a quadratic equation by factoring, by square roots, or the quadratic formula. But remember, only the quadratic formula is the one that will work every single time. But square roots will work sometimes, and factoring will work sometimes. So if you were asked to solve this quadratic equation, in my opinion, I right away notice that this does not have an x term. It just has a squared and a number. So I know I can use square roots. So guys, I know I can get x squared by itself by minusing 12. I can divide both sides by 3. And now x squared will equal -4. So we're trying to find the x-intercepts of this quadratic equation, of his graph. Where does his parabola cross over the x-axis? Well, guys, look at what it's saying. I have to find out what number could I square, and it has to equal a negative number. We know there's no real number that will do this. So to solve it, we're going to take the square root of both sides. The square and the square root will cancel, and x will equal. Remember, it's still a quadratic equation. I'm still supposed to get 2 answers, right? So I'm still going to get a plus and minus version of that answer. There's 2 different numbers I could have squared to get that. The problem is they're not real number answers. They're imaginary. And now take the square root of -4. That would be the square root of -1 times the square root of 4. So x will equal plus or minus. That's I times 2. So x equals plus or minus 2i. So positive 2i is a solution to this equation. and negative 2i is a solution to this equation. So those are your two numbers that will make this quadratic equation true. But guys, if they are imaginary answers, are they actually going to be x-intercepts? No. It just means that this is a parabola that would not have crossed over the x-axis. He does not have any real x-intercepts. He's either completely above it or completely below it. These are just numbers that, guys, if you plug these numbers into his equation, yeah, they will make it equal 0. They're just not going to be x-intercepts. They're not real numbers. They don't show up on a graph. All right, so now when you solve a quadratic equation, now that you know about an imaginary number, now your answer can be real or it can be imaginary. And we're going to focus on the quadratics that end up with imaginary answers this week. All right, look here. Guys, you also could have used the quadratic formula. A would have been 3. B would have been 0 because there's 0 x's in this problem. And C would have been 12. If you used the quadratic formula, you still would have gotten those same answers. All right, last one. Let's say we had to solve this quadratic equation. Again, it's another one of those quadratics that doesn't have an x term. So I know I can use square roots. So I'm going to minus the 108 to the other side, get x squared by itself. Divide both sides by 6. And x squareds end up equaling negative 18. So now when I solve, I'm going to take the square root of both sides. That'll cancel. X will equal. The minute I take the square root of a negative number, I now know that this equation doesn't have any real answers. It has imaginary answers, not real ones. So I now know that this is a parabola that does not cross over the x-axis. He does not have any real x-intercepts. The only thing we're going to be able to find are numbers that make this equation true. And they're going to be imaginary ones, but they are not physically x-intercepts because they're not real numbers. All right, so I'm going to break this up. First of all, I should get two answers, plus or minus. The square root of negative 1 times the square root of 18. X equals plus or minus the square root of negative 1. That's our I. That's where the imaginary number comes. Tomash, you all right, bud? All right, and then you should be writing it down. The square root of 18. The square root of 18, I can't take his square root, but I can simplify it because 9 divides evenly into it. So I can break him up into the square root of 9 times the square root of 2. And then x will equal plus or minus I times 3 times the square root of 2. And then we just fix up that order. So x will equal plus or minus I times 3 is 3i times the square root of 2. So one answer is when x is positive 3 times I times the square root of 2. And your second answer is when x is equal to negative 3 times I times the square root of 2. Which, guys, when you do 3 times the square root of 2, it's just an ugly decimal times I. It's a very ugly imaginary number. So again, what it means is that his parabola doesn't cross over the x-axis because the only x values that make him equal 0 are imaginary numbers. So the only x values that make this equation true, they aren't real. They're imaginary. So his graph won't cross over the x-axis. These are just numbers that will make his equation true. All right, everybody okay? I know that's weird, guys. You've lived your entire life dealing with real numbers in math, and I just threw an entire curveball at you by saying, hey, guess what? Now we have imaginary numbers. I know it's crazy, all right? All right, so tonight's homework is just going to focus on you simplifying negative square roots. Just can you get the I out and simplify the square root accordingly, okay? Your homework is on Delta Math. It's 12 questions, and it's due tomorrow night at 11:45. But guys, I just want to throw at you. Remember, I am not here on Wednesday, Thursday, Friday this week, all right? I'm away. So tomorrow is our last Google Meet for the week. All right, on Wednesday, Thursday, and Friday, I'm just going to leave you guys with very, very small assignments to do each day. All right, that's it. Something really quick, no Google Meets, until next Monday after tomorrow. Tomorrow will be our last Google Meet for the week, okay? All right, if you have no questions, let me double check the attendance and you're gonna be good to go.